Hello everybody, welcome to this channel. I'm Mehdi and in this video we are going to talk about the risers, their functions and design in casting. So let's go over them in metal casting. Actually, a riser acts as a storage of molten metal that flows into the mold cavity to offset any shrinkage that happens as the casting solidifies. This prevents shrinkage defects, particularly in the heavier parts of the casting, which are more prone to these issues. Shrinkage itself happens in three phases. First, while the metal is still liquid, then during the transformation from liquid to solid, and finally while the casting cools as a solid. The gating system or feeders handle the shrinkage in the fully liquid stage, but risers are crucial for the second stage, where the metal is solidifying. Placed strategically at points expected to freeze last, risers ensure that they remain liquid longer than the casting and supply metal as needed during the solidification, keeping the final casting free from voids or weak spots. Well, risers play an essential role in the casting process. Their primary function is to supply additional metal to offset volumetric shrinkage, ensuring that the final casting has no voids or weak points. Beyond this, risers also allow gases within the mold to escape, which is critical to avoiding gas-related defects in the casting product. In addition, by applying slight pressure on the solidifying mold, risers help capture the finer details of the mold, leading to a casting that replicates the original design with greater precision. Right, designing a riser requires careful attention to its size, placement, and shape. The riser needs to be the last part of the casting to solidify, so it can continuously supply molten metal to areas that are still shrinking. Achieving this typically means ensuring the riser's volume to surface area ratio is greater than that of the casting. If this is not possible, we can delay the riser's solidification by external heating or by incorporating exothermic materials. Riser placement also plays a key role. Each riser has a limited effective range or feeding distance, so we need to space risers accordingly across the casting. Finally, the shape of the riser impacts its effectiveness. Cylindrical risers are usually preferred since they balance ease of casting with functionality, while spherical risers, also more efficient, are challenging to cast. And finally, risers act as storage that supply liquid metal to a casting as it solidifies, as I mentioned before, preventing shrinkage defects. To do their job, risers are designed to stay molten longer than the casting. So, some rules help us calculate the exact size of a riser to ensure it solidifies after the casting itself. This is essential since any early solidification in the riser would cut off the molten supply prematurely, so leading to shrinkage issues. The riser volume should be minimized to reduce waste, but the shape typically aims to increase the volume to surface area ratio for slower solidification. There are several riser designs, each with distinct characteristics. A side riser, for example, connects to the casting through a small channel, while a top riser attaches directly to the casting's upper surface. Open risers are exposed at the top, losing heat faster and solidifying more quickly. Blind risers, on the other hand, are enclosed, retaining heat longer to ensure a steady supply of liquid metal till the casting solidifies fully. Well, it was a quick overview on risers, their functions and designs in metal casting. If you have any question or comments, feel free to ask in the section below. Thank you for your watching. If you found this video helpful, please like and subscribe for more. I'm looking forward to sharing more videos with you in the future. See you then.